Assalamualaikum and hi. Our group, we are from group 40. Our group name is Todak. So this is our presentation about assignment SSCE2193 Engineering Statistic. So the general instruction is we need to provide a report and video presentation about the Lajak Laku top management. So here we go.
Assalamualaikum. My name is Muhammad Sofi. So today I want to present question A. Question A is asking for describe and summarize our data to a graphical form. So in this Excel, we have three type of table, which is morning shift, evening, and night. So for every table, we have three type of data, which is weight, relative density, and tensile strength. So from the data, we can make a graph. We use the histogram graph. So the graph for the x-axis, we have three type of shift, which is morning, evening, and night. So for each shift, we have three type of graph. The blue one is stand for average of weight. The red one is stand for sum of relative density, and the white one is the sum of tensile strength. So for the y-axis is the range and average of the data. Then we can go next to the graph below. For the example, we can see the highest sum of relative density is in the morning shift. So from the data, we can compare data with the other shift. For the example, we can first we can give example. We can see in the morning shift, the sum of relative density is the highest than the other shift. So we can move to the other graph. So here our frequency table, which is from question B, that asking for build frequency table. So here our graph for frequency data. The x-axis is stand for weight, and the y-axis is stand for frequency. So for each range, we have three type of graph. The blue one is production shift run morning. The red one is production shift run evening, and the white one is the production shift run night. So that's all from me. Let's move to the question B.
Question B. The question asks to comment on whether the weight of the data for every production shift follow the normal distribution with 350 milligram of mean and standard deviation of 14 milligram. So from the question and from the data for Lajak Kuruih J, we summarize the data. First, we make the frequency table. From the data, we make a suitable range for the value to be in the frequency form. In order to get the frequency of data within the range, we make the frequency table. After that, we make the table of OIJ and EIJ. OIJ is the frequency of the every data, while EIJ is the mean of the data. After we make a table for EIJ, we need to make sure the value of EIJ need to at least 5. EIJ value must be at least 5. If the value is not larger or equal to 5, we need to sum the value with the upward value. So we sum the value for OIJ for 0, 1, 2, and 5. Including the value of E, we sum the value of 0.96, 0.915, 1.125, 7.3600, and we get our new table, which is modified table. After that, we need to calculate the value of OIJ tolak EIJ square divide by EIJ. Total value of this we can calculate as X square test. Then after that, we need to do the goodness of fit test. The goodness of fit test is a statistically hypothesis test to see how well sample data fit a distribution from a population with a normal distribution given. This test shows if our sample data represents the data we would expect to find in the actual population. For our question, we take the level of significance at 99%, which is alpha value is 0.01. General rule for the question is has not always follows the normal distribution or fit or the something for the condition. For this question, our H naught, the way data is followed the distribution. But for H1, the way data is not follow the distribution. The decision rule for this test, we reject H naught if x square test greater than x square 0.0114, which is the value is 29.1412 that we got from the statistic table. Then after we calculate the x square test from the modified table, we got the value is 4.6847, which is less than x square 0.0114 that we got from the table. So follow the decision rule. If the value of test is greater than from the statistic table, we must reject. But the decision we got is less than the value at the statistic table. So we fail to reject the H naught. So as conclusion of the goodness of fit test for our data, we can conclude at 0.01 alpha at 0.01 level of significance. The weight data is follow the normal distribution with the mean 350 and standard deviation of 14. So that's all for part B. I pass to Shafiq Aiman.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Shafiq Aiman Rasbandi. Today I will be discuss with you about question C that comment on whether there is any significant difference between the tablet weight from the different shift. So in this question they have a 3 shift, so we must use the ANOVA. So from the production shift, we get the summary that we use Excel to get the summary. And okay, for the summary, we get the data that produce count, sum, average, and variance. So for the ANOVA, we want to calculate the F calculated. So we get source of the variation between group and within that the SSTRT we get 80.1. For SSE we get 721.6. For the total SST we get 39.78. So the F calculated that we get for the ANOVA is 0.188. For the one-way ANOVA test, we H naught equal to A1 equal to A2 equal to A3 equal to 0 that represent morning, evening, and night. For the H1, A1 not equal to 0 for at least one I where I is equal 1, 2, and 3. Okay, for the decision rule, we will reject H naught if the F calculated is bigger than F we get from the table. So the decision is F calculated is 0.188 2217069 is less than 6.11 that we get from the F table. So we will fail to reject H naught. So the conclusion that we get is we can conclude that at the A equal to 0.01 level significant, that there is no significant difference because between the table weight from the three different shifts, which is morning, evening, and night.
Question D, my name is Mama Hafiz bin Karudin. Okay, so for question D, the question asks to predict the tensile strength for this pin. They give values at 68%, 74.3%, and 80.1%. So we do simple linear regression to get the summary for this Lajak Kuruih. So from that, we get this table that alpha cap and beta cap. So the intercept is alpha cap and the relative density in percent is the beta cap, which is the gradient. So from that, we got this line fit plot and this equation that y equal to beta cap x plus alpha cap. So from the information, from the question, we need to substitute the value that provided in the question to get the tensile strength. Then we calculate when the relative density is 68. 88%, then we got tensile strength equal to 5.39. Then we input the relative density equal to 74.3. Then we get tensile strength equal to 5.93. After that, we input the relative density equal to 80.1. Then we get the tensile strength equal to 6.43. However, for the validity, the three of this input for relative density will be rejected because from descriptive statistic, we got the minimum and the maximum for our statistic. We got the minimum and the maximum for our relative density is the minimum is 83.6 and maximum is 65.2. So from the input that give in the question are not in the range since that we rejected the relative density, and then for the validity it's not valid in this statistic. So value that we can predict in the next time is in the between minimum and the maximum from the descriptive statistic, which is 83.6 till 95.2. Thank you. That's all from us.